In a random sample of 40 families with one dog, the mean amount of money spent on dog expenses was $139.80, with a standard deviation of $25.40. Find an interval estimate for the mean amount of money that families with one dog spend on dog expenses per month, with a 95% level of confidence. First, let's have a look at what information we are given. Now, we have a mean, $139.80. We symbolize the mean with the symbol x bar. We also have a standard deviation of $25.40. We'll need that as well. We'll symbolize that with the letter S. We also have a size of the sample given to us, 40 families. We'll symbolize this with N. Now, if we want to make a confidence interval, we'll say our lower bound will be x bar minus the error, and our upper bound will be x bar plus the error. So our order of business here really is to find the error. To get the error, we'll have to assemble this equation. E is equal to t critical times S divided by square root of n. Now, S and n we already have listed. However, we need to talk about how to find t critical. We have a confidence level of 95% or 0.95. Now, we'll need to get a quantity called alpha, which is simply 1 minus the confidence. Then, to find t critical, we'll use a special Excel formula called t.inv.2t. And inside that function, first we place the alpha, and then we place n minus 1. The reason why we're using t rather than norm is because we're not going to use a normal distribution for this. Instead, we're using something called the t-distribution. It's similar to the normal distribution, but has larger tails. So you can think of this as an approximation of the normal distribution. Now, just like before, where we used to use norm inverse for previous problems we've done, we're still using inverse, and we're including the 2t to cut out some of the math. If you include the 2t on t inverse two-tailed, we don't need to divide the alpha by 2 like we did in previous problems. Now, the alpha is also called the significance level, and the n minus 1 is sometimes called the degrees of freedom. So with all these equations, let's go through the process. Step 1 is to enter in the given information. Step 2 is to use our confidence to calculate alpha and then t critical. Step 3, using the information above, we can calculate error. And then step 4, once we have our error, we can get the lower and the upper. Let's enter spaces for all of the things we need. At the top, we were given the mean, the standard deviation, and the size of the sample. So we'll start there. Our mean, once again, was $139.80. Our standard deviation, $25.40, and our n was 40. Now our confidence was 0.95 also. Based on the confidence, we can find alpha. That's just equal to 1 minus the confidence. Now after that, we can get t critical. For t critical, we'll say equals t.inv.2tail. We'll enter our alpha, comma, n minus 1. Press enter. That will give us our t critical. Once we have all of those numbers assembled, we can find the error, which is equal to t critical multiplied by standard deviation divided by square root of n. When we press enter, this will give us our error. Then we can find our lower and our upper. So our lower is equal to x bar, or the mean, minus the error. And the upper is equal to the mean plus the error. So our final answers are $131.68 if we round to the nearest cent, and $147.92. We'll paint this gold by clicking on the gold paint bucket, and we'll format this as currency by clicking the $ in the number section. Let's draw a picture also to go with this. Our lower boundary will be $131.68. Our upper boundary will be $147.92. Now question C says, suppose we know that the mean amount of money spent on a reptilian pet is $116.63 per month. Can we say that the mean amount spent on a reptilian pet per month is more than the mean spent on a dog? Let's have a look at the confidence interval. So we have this confidence interval between $131.68 and $147.92. Now, according to what we've done previously, we can say that the true mean for families with one dog is between these two numbers, and we can say that with 95% confidence. Now, the mean that's being spent on a reptile is $116. So let's mark that on our number line. And that's definitely lower than 131, so that will be somewhere to the left of it. We are being asked if the amount spent on a reptilian pet is more than what you would spend on a dog. According to our picture, it looks like the amount spent on a reptile is definitely less. So if we were asked to answer this question, we would say the amount spent on a reptile is below the confidence interval spent on a dog. Therefore, we cannot reliably say that it's more. Now, had the amount spent on a reptilian pet been above $147.92, in that case we could say reliably that it would be more.